Okay. All right, cool. So for the jump starter session today, we're just gonna do some JavaScript problems. So basically, I will try to uh, solve it, and then everyone can follow it as well. So there you go. So because we just pick one random problems, I was thinking that we're gonna pick something easy first, and then for the next half, we'll do like a medium or a hard one. Mm, give me a second. Okay. All right, cool. So we're just gonna do a shuffles. So this is the basically the website I'm gonna do is on Edabit. So we're just gonna generate something easy. Then I'll post the questions on the chat. Sum of cubes sounds plenty. So I'm just gonna do this, and this is the questions. So since this is my first time doing this, I'm just gonna try to do it by thinking my thoughts out. So I don't know. So and then if you choose to do it yourself, that's fine too. And then I think we only have one person today, so you can just compare the answer if you want, Ching Hong. All right. Right. So for the first one, this is the sum of cube. Create a function that takes in an array of number and return the sum of its cubes. So, for example, if you're given 159, you're gonna get the sum of the cube of each number. So 1 to the power 3, 5 to the power 3, 9 to the power 3. You sum it up together, it's going to get 855. All right, let's.
Oh.
So I think I'm gonna do it on my VS Code. So I think this is better. So I'll just do this. New files. So base date is September. I'm just gonna do this script.js. So for the comment, we can do September 5th, 2022. Start the session. If you cannot see my screen, just let me know. I think I'm going to do this.
So Nelson, can you zoom in bigger?
Yes, I'm trying to. I think it's smaller the side too. Yeah. Zoom in. It's the shortcut for it. Okay. Is this better?
Yeah.
Okay, cool. All right. So basically, for the first problem today, we're just gonna do sum of cubes from a bit, so that just for future reference. We're just gonna copy the test case from here. This one should get 85. This one should give 168, and then 0. So this is our test cases. Test cases. All right. So to this function, sum of cube, taking an array of numbers, and so in order to do this, this is what I am thinking about. So for pseudocode, so we're just going to try to break it down to a smaller piece of problems. We know that it is always going to be an array. So, what we're gonna do is we're gonna first check the. I think I'm gonna do this. Check the array is check if the array is empty. Because in this case, the last one, we have an empty array. And the second one will be go with and look through the array. Through the array. And we're gonna take take each element and find its cube. So basically multiply 3 times. And we will initialize variable, no, initialize the basically a sum element, sum variable. Is it called variable? And then we're gonna do the sum it up the rest of the cube. I'm gonna do this on the next line. Sum up the elements. And then lastly, we're just gonna return here functions and return the sum. So this is the pseudocode. So let's give it a try. We're gonna initialize something called the sum. Let sum goes to 0. So this is something that we are going to sum it up for the rest of the loop. And then I'm gonna do a for I equals to 0. Array dot length. So I is less than the length of the array. Just gonna do the increment. Yes. So next we're gonna take and do some goes plus array brackets I. So that's the each elements of the array. And then we would return sum. But before that, let's give it a try first and see if we can get errors or not. So we do console.log stop. Oh, forgot one thing. So I need to multiply this by 3 times. So I do this. Let's make it cleaner. Cube equals to array I times array I, and then we're gonna times it again. Do a space up so it looks cleaner. And then we're just gonna do a cube. Clear output. Okay.
Wow, nice.
That's good.
Nice.
So to explain everything is just the way I did it is I initialize the sum as 0, and then as you look through the array, we just get the cubic of the element, and then you just sum it up into the variable sum, and then in the end you should be able to get the answer. So let's try this in the terminal. Test. Does it do it here? Skip code. Oh, there you go. So we just in that case, yeah, arrays is actually num, so we just change this to and this one I don't need. I don't need either. So let's check. Cool, it passed. Any questions? Jinghong, any? Is it okay for you?
No question.
No question. All right.
Looks good for me also.
Okay. So that's the first one. Okay, so if no questions, then we will proceed with medium questions. Oh wait, this asking me like the
Yeah, I think that one was a review.
Was it asking me like the how was it, or like
Yeah, I think so. That's the I just remember that's how Adabit works also.
cool. It's okay, we'll try this one. Convert a number to base 2. So create functions that return a base 2 binary, represent a base of 10 string numbers. To convert is simple. 2 means base 2 and 10 means base 10. So this is the binary. We've converted into decimal. Going from right to left, the value of the most right bit is 1. Now from the every bits to the left would be times 2 of the value. Value of 8 binaries numbers are 256, 128, 64, 32. And binary of 1 is 1. Binary of 5. Oh, it's basically just us to convert it to the binary number. All right. So for this, just comment this out first. So for second questions, I'm gonna copy this and put it into the chat just in case if you want to look at it. And yeah, let's try this. Seems slightly difficult, but sure we can do it. 2 base 2. This one I think requires a little bit of math and computer science knowledge. From what I understand, is basically goal is to convert decimal to binary. For those who don't know what binary is, who's watching this video who doesn't know binary is, it's basically the 1010. So this is not the right. So basically this is binary, and there is a way for you to get from decimals to binary, which is from binary to decimal is multiplied by 2 to the power for each of the element. But starting from the decimal to binary could be a different cases. So let me see. Give me 1 minute.
I think for this one, right,
You have to divide by 2.
groups of 2, right? You need to divide by.
Yeah.
You need to check from the largest power first, because the smallest power is always easy to check. It's the bigger one that will determine, whether it's used or not.
Okay, so 1 is easy because it's just 1. Binary for 5 would be 1 to the power 1, and then 4 to the power 5. Right, let's list it down first. So say if we have a number, a binary, say like 1, 0, 1, 8, 1, 0, 1, 1, 0, 1. To understand it for those who are viewing the video run. So for this one, it will be 2 to the power 0. And this one will be 2 to the power 1, 2 to the power 2, and so on. 2 to the power 3, 2 to the power 4, power 5. So this. Um, and then you basically get the times 1 times 2 to the power 5, you get a number, and then you just sum up anything that has 1, and you should get the decimal of it. For you to reverse, it'd be something like you might we just give it a try first.
Wow, this one need a lot of check cases.
So just his cases. This is my first time working with binaries on JavaScript.
Yeah, same. I
Done it before, and then I completely forgotten how to do it.
oh, I haven't done this.
All right, we just give it a try.
I think definitely can one. It's just the logic flow for it is gonna be very interesting.
Yeah, I think I was thinking that we should start from the small one, because it seems like, so say 2 to the power 1. To the
I
power.
feel it's easier to start from the big one because one can fit anywhere. Meanwhile, on the other hand, right, let's say, okay, why don't we write on this one, right? We write what is the value.
Okay. Right
So
here.
that means 2 by power 5 is 32. 32, 16. Oh, nice. So you can go all the way to 256.
Yeah. So we do it's easy viewing. But in this case, if we are following this example, example would be like 2 plus 0 plus 8 plus 4 plus 0 plus 1, and then it is sum of it. To explain it to the viewers of the videos, is basically if you get a number 1, it should get. I think I got it on your mind. If it's a 0, you should get a 0 from this. It's basically 0 multiplies by this, and you get 0. But if it's 1, then you get 16s. So in this case, it would be 32 plus 8, 40, 44, 45. For the example, it would be this number, it would be 45 in decimal. Well, one thing we know is we know this pattern. So if we can check the number that is given is bigger or smaller than this, then we will know where to start. So pseudocode. First, determine the value of decimal. And then determine that the value of decimal, find it the range of 1 to 156, and then mean the value is not small, find it if it's within the range of 1 to 260. And then
I think we
start from the, I was just figuring out how to explain it. Because if it's like something that is more than 16 but less than 32, then we know that it's only right here. But how do we call this, like bit places? Values of an 8-bit binary cycle.
means the earlier index and all that will be ignored. Only the
Yeah.
last few indexes will be included in our next checking.
Mhm.
So it's either we remove, I think we remove the front, or we extract the last few. This one also we need like a splicer, I think.
Yeah, I need to spice it out. So we'll call it, say, splice out the
Number before the index, or the selected index.
number.
The thing that meets the condition, meet condition of number 2. The index number that meets condition 2.
Of the conditions. If it finds within the range of 1 to 256. Oh wait, I just realized that the number is alwaage b's, so it has to be like 124.
Oh yeah, less than 1, 2.
That's the edge cases, I believe. So, but it's not including 224. Like 23. An operator could be useful. Okay. This the compare thing.
So must be in between, no? Must be in between the thing, or else you generate an error or something.
Yeah. The string will always go to the length at which the most left bits values get bigger than the decimals in decimal. The string will always go to the length at which the most left bits value gets bigger than the number in decimal. If a binary conversion for 0 is a temp, return 0. Okay. So this is the edge cases. Before the index and it's okay. Let's try it. So if we're gonna do some edge cases, so if decimals is 0, then we return return 0. And this is the edge case. Next. So we know that it's from 1 to 123. 2 to the 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 bits. This one is 512. So it'll be like 9 bits. Okay. To initialize so we can do this let binary result goes to this, and we're just going to append it based on the condition.
Do we need a check case for the bits?
The bits.
What's the default value? 2 by power 5, 2 by power 6.
2 to the power 5 to the power 6. All
the way to 2 power 0.
I mean, the other options is to do it using object. So basically,
True, you could do that also.
But how?
Or an array. We could do an array. So it's either an array or an object.
Okay, let's try this. So. Something like 6.
Yeah, I think JavaScript has the power. Yeah. Or we could use that also, actually. Yeah, we could use that.
I'm doing the Java way.
Yeah. 10. 2, 5, 6.
1. I think I'm still missing this, right? From 1, 2. So here total would be
That's correct.
Just gonna do this to see some. Well, I don't think there's a sum. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh yeah, we need a 0 also. Hey, is it a 0? Wait.
But 2 to the power 1 would be.
Oh yeah, true.
1, right?
2, 4, 6,
0 to
8,
1.
10. 2, 4, 6, 8, 10. Yeah, I think 8 bits. Oh. I think because it says base 10, right? No, sorry. Not base 10. It just tells us that it must be less than 1024.
So if it's 1024, then we will need the whole thing, right?
Yeah, the whole thing all add up will become 1023.
And then if it's less than 512, you'll be only need this part. Yeah, okay. But the question is, how do you determine that?
Okay, so if it's below, okay, let's say if it's 700, how do we know if it's 7? What would we use for 700?
If it's 700, so let's do it on paper. So if it's like 700, right? Meaning that we will need this.
We'll take the largest one. That leaves us with 188. Then from 188,
Yeah, 188, right?
right? From 188, we wouldn't select 256 because it's too large. Because it's too, 256 is too large.
256 to us, and if this one would be 0, right?
Yes.
So this one would be 1. And then
Yep.
56 is it too big? And then so we start from here. Actually,
Yeah, so if it's above, so if it is less than the check thing, then the thing will store a 0 or we store a 1.
Yeah, we'll store a 1.
Yeah, so we can store 1 or 0s into the final result.
Okay. And 1. And so this one, 128 would be
so it's
60, right?
Yeah, 188
is 2 to the power 6. And
I was thinking maybe we can do it row by row so that we can see the flow easier.
oh, okay.
So like 128 or something. Okay, nice.
So T is between 4 and 32. So we take 32, which is 2 to the power is 5, right? So 2, so 28. And then 28 is between 32 and 16. Minus 16, so we'll get 2 to the power 4, which is 8, 6, that'd be 12, right? Yeah, 12. And minus 8 between 16 to 8, so you will get 2 to the power 3. And then we'll get 4 in this case, and minus 4, which is 2 to the power 4 is 2, right?
Yeah.
Okay. And then in this case, we get 0. So
once we reach 0, then we stop the whole checking loop.
Okay. So in this case would be 188 is less than 56 is bigger than 8. So 2 to the power 7. 1. 1. 8, 7, 6, 5, 4, 3, 2. And then the rest is 0. So 2 to the power 1. Let me do a quick Google check.
Will you guys be able to do it?
Yeah, it seems okay. I think I just need to figure out the steps for it. So, decimal, binary. 101, 101, 1111,
10101.
oh, it's 10.
101 11100. Yeah, it looks correct.
It looks correct, right? Yeah.
I'm missing one zero. There's a zero missing in between. 8765431. Oh yeah. Oh. Oh yeah, it's correct then. I think because they put two more extra numbers in front.
Oh, okay. They're doing like okay.
10 bit, is it 10 bit? Yeah. I think it's 10 bit. Ours
10
is 8 bit.
Okay, I see.
Mm.
So this is correct. So we're just gonna do this. Put it here. Oh, and binary.
Oh, by the way, I'll make myself a bit first. Eat my dinner, but I'll be watching.
Okay. Mm. Okay, so we're gonna take gonna check the for I is equals to 0, I is less than.
I was thinking, right, why we use a while loop? Oh, but never mind. You continue this one first. Yeah, I'll try explore while loop version later.
It's okay. I can try while loop because I used to do a lot with while loops too.
Okay, nice.
While
I think while the decimal that we get in is less than 0. Sorry, it's greater than 0.
Right.
Mm.
it's not
So
equal
this
to
one needs to keep updating.
and we need to keep track of so this would be 0, right? I think we need to do this let index equals to 0. Actually, if I do another array, to 8, 6, 5, 7, 8, 6, 5. zero. So this one would be mimicking the power of this. Track. So we take if the powers of this index is larger. So this index is larger than decimal is the number. Oh, this is wrong. This is here. If this one is larger than the decimal, that's
Then the
no.
this will be a 0, right?
To be a 0, right? Yeah, this will append 0.
So like if it's a 400, so 512 is bigger, so you append a 0.
My result would a 0. And then else the binary result. And 1. At the same time, we need to reduce decimal equal to binary. This is index. And of this index would
Yeah.
Okay.
That looks correct.
That's right. Because I think there's probably a bug there, but so this one will return so.log. Okay. It is correct. Wait, no, it is not for the 10. Because we skip if it's not looping through, if it's 0, right? So say if we get to this point, it will stop appending this because it's outside of the loop.
Oh,
It's 2-0, it will not be appended.
I see.
There need to be another condition. I think it's index is less than the length of this thing. But then if this condition is not fulfilled,
This would be, in order to for it to keep running, your index must, if you could go to 0,
so it's less than the bit length.
or could we just do an if else check at the end? And then if the index number is not 8 yet, then we'll add in the X amount of zeros to the
Okay, I see what you're saying there.
to the binary result. So this would be after the while loop has been exited.
If the index is less than the
8-bit dot length.
dot length, right?
Yep.
This one is just for reference. If this is less than the 8-bit dot length, so if, for example, if the index is, in this case, would be if the index, say, for example, this one is 1, 2, 3, 4, 5, 6. If it's only 6 and you finish 6,
It's 6 and you
7,
have 2 more left over, right? So
Yeah.
if 2 more left over, we need to get the difference and then loop through that difference to add the certain amount of zeros.
dot length minus index left over. Or that I is no, it's doing another while loop too. Over is equals to 0. Binary result and 0.
Yes.
And should return it. So let's try.
And we need a decrement for the leftover.
Okay. Over
Minus, yes.
okay, that's correct.
Oh, nice.
Need to ignore the
Part. All right. Okay lah. I think we like.
yeah, it's
Send
nice. Okay, I'll post this on the GitHub, and we're supposed to post it on GitHub, right? So that people can refer to it.
I think we can. Oh, by the way, is it okay if you just share screen again? Is everyone still here? We can just turn on the video a bit. Yeah, I just want to take a nice screenshot to show our marketing team.
Yeah, sure.
Nice.
Well done, Nelson, on that one.
Sorry?
Well done, Nelson.
Oh, thanks.
Good stuff. Okay.
Okay. So
Chin Hong, are you there?
Okay, nice. All right. Yeah. Just open that and everyone just look at the camera. All right, 1, 2, 3. Okay, nice. All right. Thanks everyone. Looks good.
yeah,
And
just get
Jin Yong,
Yes.
by the way, next week will be for discussion, right?
Yes, that's correct.
So I maybe prepare some question or how?
That one